characteristics of the ocean, which is lesson 6.01. So we're going to take all the notes on that so that you don't actually have to go through that lesson. You can go straight to the quiz when we're done. So our objectives are going to be define and describe ways to avoid plagiarism in this class. Explain the engineering and design mini projects. Describe how oceans are formed. Describe major characteristics of oceans. And then identify human impact on the oceans. We're going to briefly touch on. We're going to touch on that more in the future. I did include a statistic that I think you guys will find disturbing. So let's start off by having everyone in the chat post one thing that you know about oceans. They're big. It's a thing. They're large. Okay. Things we know about oceans, they're big. What else? It's mostly undiscovered. Okay, that's good, Amanda. Salty. They are made of salt water, yes. Okay, good. So we have some general concepts here. They have animals. They're blue, right? Yeah, right? We kind of have a vague idea. So we're going to kind of talk about how they form and the major characteristics. Specifically, we're going to talk about salinity and temperature. So, full of organisms, yes. Organisms that make oxygen, oh yes. Algae, right? I don't know if you guys have ever had algae touch you, but it doesn't feel that great to me. Okay, there's more than one, yes. Okay, good. Oh, I'm so happy, guys. I just had my chemistry virtual session and no one would talk to me. And then I remembered earth science is next, people talk. Okay, so plagiarism. It's not just an essay or paper thing, right? What is it? I know you guys have taken quizzes on this in your English class and in mentor seminar possibly. So what is it? What is plagiarism? Cheating, that's a good short way to say it. What would we say if we wanted a sentence? Copying, taking someone else's work, copying other people's work, copying things that are not yours. When you copy someone else's work, all right, good. Not paraphrasing. Taking other people's work without giving credit. Thank you, Juliana. That's a perfect one-sentence summary, right? So there are times when you do want to take other people's work, right? It's not like you never want to look at what someone else is doing. You might want to quote them, right? You might want to quote something they said. You might want to quote something they wrote. Of course, you then give them credit, right? You say, oh, Dr. blah, blah, blah claimed that oceans are formed by blah. Okay, that's great. He knows that and you got that information from him, right? Plagiarism can be you copying something from the internet, you copying something from your friend, you copying something from a lesson or textbook without giving credit, right? It could be a lot of different things, which is part of why it's confusing. Right? The other hard thing is sometimes we think we're paraphrasing and we're not necessarily, right? So why do you think people plagiarize? And if you've plagiarized before, you might have a good insight into yourself, but why do people do it? Taking an easy way to finish, right? Yeah, you're running out of time. It's due right now. And you're like, oh, I don't know. Or you just don't feel like trying, right? They're stressed. They want to get things done. Yep. You don't know the answer. Yeah, you read the question and you go, let's just see what that says. Definitely, right? Not knowing the answer is a good reason. Being stressed, wanting to finish. Too lazy, right? Laziness could be it too. Like, oh, I could look this up and think about it, but I'd rather just not do that. Well, here's the thing, guys. I've been teaching for quite a long time. I can tell usually, I'd say I have about an 80% accuracy rate of when it's written by a student and when it's not, right? Especially based on sentence construct and context. None of you guys start your sentences with a clause. If I see that, that's a big, big sign that it's plagiarized, right? Also, words you're using. Are they vocab words that we've never discussed in the class? That's weird. Why would you use that word, right? Is it a very advanced word that you probably wouldn't say because I've read your work before and I've never seen you use words like that, right? All of these things cause me to then investigate you. And if you've plagiarized once, I check every answer that you turn in after that. If you use Brainly or OpenStudy, I will catch you, right? I might not catch you the first time, but I will, right? I Google the questions from the class and I look at Brainly and I report on Brainly and I send them rude emails about how much I hate them and how much they're profiting off of cheating, and it's very messed up. I considered trying to pay money to have Brainly DDoSed, right? But it was too expensive, so I didn't do it, right? OpenStudy became Brainly, it's the same thing. I look, right? I see this stuff too. Now I know, I didn't write the questions for this class. Some of the questions suck, right? I'm the first one to admit it, right? Some of them are bad, right? They're worded really confusingly. Maybe there's so many answers you don't know which one to pick, right? So here's the thing. Can you define any of the words in the question, right? Is there a word such as subduction? And you're like, what does subduction mean? Maybe that will help me answer the question, right? Try to define the words in the question to see if that helps you, right? If it doesn't, send me a text or an email. If it's in the school day, I'll respond pretty quickly, right? It might be an hour, right? It might be 3 seconds, but you guys know I'm always on my email. I will respond to you. If you send me a question, hey, I don't understand number 25, paste the question so that I can easily respond, right? And I can reword it for you. I can give you a hint. I can suggest a way to answer it. Take a guess, right? You could even write in your answer. I'm going to read them, right? Hey, Miss Jamie, not sure if this is right, but I think this question means blah, 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 blah. You never know. You might have gotten it right. At the very least, I'll give you points for trying, right? Very rarely do I give 0 points on a question that you've tried to answer. If you're totally wrong or you don't answer what the question asks, I usually give 0 points. For example, if the question's asking about absolute dating and you write about relative dating, that's not what the question's asking, right? Leave it blank as a total last resort. Like you can't even think of something to guess. I didn't respond to you for some reason, or you're doing your schoolwork at 1 a.m. I'm not going to respond to you. It's better to get 0 points on that question than to get a 0 on the entire quiz, test, project, right? I don't have sympathy for you. I never cheated, right? And I actually really get upset when people cheat because it's not fair to the people who are trying. I do have sympathy, though, if you're working hard and you're trying your best to answer the question. And you're writing, I'm not sure how to do this. Here's what I know. Here's what I think. Right? Of course, another thing that's going to help you avoid this is if you're taking notes, right? If you're writing these things down, you can look in your notes. Oh, this is what that means. Oh, this might help me answer it. If you're not taking notes, the first thing you're going to do is Google, right? Because you have nothing to go back to. So make sure you're taking notes. Even if it's just writing the vocab, you can even print the glossary of vocab off from Canvas, right? So you have all the vocab printed. That would be helpful. I'll give you feedback on stuff. If you say in a question, I think it's this question mark, I will tell you what it is, and then you can write that in your notes and know for the next time, right? A lot of these questions get reused. So if you get it right the first time, it's great. You're going to get it right again. If you're not sure and I tell you how to do it or tell you the correct answer, then you should be able to get it right the second time, right? So just be careful. I've seen a lot so far, and it's the very beginning of the semester. Eventually, you could end up getting an F in the course, right, if you plagiarize enough. Okay, end rant of plagiarism. Engineering project. A lot of people already started turning this in, right? It's basically an essay. You have 3 choices. A few people were confused on what the choices actually were because you had to read in the lesson to find out what the choices were. But they are unclean water, air pollution, or limitations of space exploration, right? Essentially, you're going to be writing about facts, right? And then you're going to be writing about possible solutions to one of those issues. So pick one that's actually interesting to you, or maybe one that you know about already, right? If you already know a lot about air pollution, great, then you're going to write about it even more. Ian, you're 100% correct. You can get kicked out of college for it the first time. They don't care. Oh, but I didn't have enough time. Too bad. You literally get kicked out of college and you don't get your money back, right? In fact, I know someone who got kicked out of a PhD program. They were 5 years into their 7-year PhD and they plagiarized one paragraph of a paper and they got kicked out. Could not get into any other programs and basically paid for 5 years of school that they didn't get to use because they never got their PhD, right? And they don't care why you did it or whatever. They don't even listen to you. Okay, anyway, 4 parts, right? The first part was just picking your topic and your sources. So you need to write about why you're using the sources to show me that you actually opened the source and looked at it. If you're having a hard time with sources, you can email me, right? I had a couple people email and ask about those, right? I can suggest some to you. I can suggest some ways to find good sources. If you do a really great job on this essay, in other words, you turn in all 4 parts, you show response to feedback, you put in 100% of your effort, right? I will let you use it to either drop your lowest assignment grade. So let's say you got a 50% on an assignment, you can actually just have that grade, whoop, dropped. Or you can add 10 points to a test or quiz. So that's pretty cool. All from doing something that you have to do anyway. If you do a great job on it, you will have these 2 options. Now, of course, you have to tell me which one of these options you want. We'll talk about this again once the entire project is turned in, right? But you'll just send me an email. Hey, I want to add 10 points. Hey, I got a low grade on this. If you got a 0 on something, can you drop it? Yes, but not a test or quiz, right? An assignment. If you got a 0 on a test or quiz, then I would add 10 points to another test or quiz so that you can really boost your grade from that, right? But if you have a 0 on an assignment because maybe you forgot to do it or you didn't want to do it, you'll be able to drop one of those assignments. Okay, now we're going to get into characteristics of the ocean. You should be taking notes at this point. All right, some of this is going to be review, right? Some of it's going to be new. Some of it is going to involve plate tectonics, which some of us might be familiar with. And then we're going to watch a couple of little videos. So I'm going to be quiet for a minute right now so that you can write stuff down without me talking. Do you want to sit over here so you can see? Or do you just want to listen? Well, Amanda, because you're an overachiever, you're going to get to sit through me talking about this. And you're going to add to your notes because we're going to watch a couple videos which you might find interesting, right? And hopefully you'll be able to help any of us who are confused on understanding this. So open your notes and add to them. You're going to want to stay for the code word. Okay, so I'm going to start talking. If you're writing, keep writing. Earth is 71% water. Okay, 97% of that is oceans. We're going to look at that graphic in a second, which is going to help us understand that mathematically. There's not a lot of fresh water, right? Less than 5% of oceans have been explored. I think Amanda mentioned that in the beginning because she had already read this, right? But especially deep in the ocean, right? So imagine how much ocean there is. 5% of it, barely, less than 5% has been explored, right? That's not very much. Now, why aren't people exploring oceans? What do you guys think? Yeah, you need equipment. That's a great point by Haley, right? Can you just jump in the ocean and start looking around? Maybe, right? But you can't go very deep. You're going to need scuba equipment, scuba training, right? And then, of course, the deeper you go in a dive, the more dangerous it is, right? So a lot of scuba divers actually die from trying to explore caves and other stuff underwater because they get trapped, right? Or they get lost and they run out of oxygen, and then that's the end. In fact, some underwater caves have signs that tell people not to go in them, right? We don't have the technology. Yeah, we can send cameras down, but guess what? It's really dark in the ocean, right? Especially when you get really deep. Can't see anything. So even if we have a camera down there, we see blackness. So really, technology is limiting that, right? And also just the dangers of people doing it themselves. Oceans and water are important in the water cycle, right? That should be common sense. We've already talked about the water cycle. If you don't know about the water cycle, make sure you review it. And then this is a little stat that I threw in here. 5.25 trillion pieces of plastic are currently in the ocean. That's a lot, right? So there's a link there to the source of that in an article you could read if you're interested. When I post this PowerPoint, right, you could actually learn about sort of what that plastic is doing, but a lot of it is sort of just floating in these weird trash piles, right? And then some of the other plastic has been broken down into tiny little pieces, and it actually is getting absorbed by marine life, right? So there's actually a pretty high chance if you ever eat fish or shrimp or any organism from the ocean, mussels, blah, 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 right? You probably have pieces of plastic in you. They're really tiny, right? But they're never going to go away. Pretty disturbing. Okay, other question that's on here. Are we treating our fresh water well? What do you guys think? If one of the topics for our engineering paper can be unclean water, to me that sounds like we're probably not doing the greatest job with our water. Right now, this has changed over time. Of course, 100 years ago, people were just dumping waste into rivers because they thought, whatever, it's going away, right? Things were on fire all the time because there was so much pollution in water sources. Haley's right. We think that we have never-ending water, right? We think, it'll replenish. It'll come back. It's fine. It'll clean itself, right? And that's not what's happening, right? So it is something to think about, even though we think, well, water, everyone has water. Well, they don't, right? They might have water, but they probably don't want to drink it. So we're going to look at this graphic here. This comes from Canvas, telling us basically a distribution of water. So if we look at all the water on Earth, 97% is oceans, 3% is fresh water. Now, if we take that fresh water, where'd my mouse go? And we blow that up, we end up seeing that from fresh water, 68.7% of it is in ice caps and glaciers. So can we use that water that's in a glacier? No, right? It's in a glacier. Now, of course, glaciers are melting, so we might be like, ooh, we're getting more water. Yeah, we're going to get more flooding too, right? So maybe not so good. Groundwater is only 30% of that water, right? And then there's 0.9% of other, right, surface water, right, i.e. on the surface of the Earth. What's the other part? That is a good question, Ian. I am not 100% sure. I would say that other is probably water vapor, possibly, in the air, but I don't know why they wouldn't just put that. Then, then from our surface water, which remember is only 0.3%, 87% of it's in lakes, 11% is in swamps. Are we going to want to be around that swamp water? Probably not. 2% is in rivers, right? So really, when we look at our water breakdown, most of the water that we interact with is a tiny, tiny percentage of how much water is actually there. Yeah, I don't know why that says other. That's really weird. This is what happens when I don't make the graphics. Okay, so how did oceans form? Oh, check out that GIF action of the tectonic plates moving. I tried really hard on this PowerPoint, guys. I put a lot of pictures for you. Because I know oceans are kind of like, whatever. So, when the Earth formed, right, we're talking about millions and millions of years ago. It was super hot, right? Like so hot that you couldn't survive. and there was just a ton of gases being released by volcanoes, ash, lava all over the place. It was basically like the apocalypse times a million. So all those gases, eventually water vapor became one of those gases, right? It was too hot for water to be a liquid. It was only a gas. Then the earth finally started to cool, right? Of course, this takes a really long time. And that water condensed and became a liquid and actually started to form some oceans. Now, a lot of us know already about tectonic plates, right? And Pangea, right? That all the continents were at one point a supercontinent and they broke apart and started moving, right? And when the continents move, they gave an opportunity for new oceans to form, right? Someone said in the warm-up, what we know about oceans, they said, well, there's a bunch of different ones. Yeah, right? All the spaces between continents eventually become some kind of ocean. So as water continued to cool and condense, right, these oceans got filled up. So tectonic plates, if you somehow have gotten this far in your science life without learning about these guys, right, you're going to learn about them now. They are the plates in the earth, right, that move. Some of them hit each other, some of them split apart from each other, some of them go under each other, right, and they cause earthquakes, volcanic eruptions, right, and in some cases, in this case, they can actually create new oceans, create mountain ranges, etc. So the fancy science term for them, other than tectonic plate, which is kind of a fancy term, is the lithospheric plate. Does anybody remember what the lithosphere is from first semester when you had to define all those spheres? You could also Google it and tell everyone and make it sound like you remember from first semester. What is a lithosphere? What is that? The outer shell of the earth. Thank you, Sydney. Nice definition. Sydney's in the room with me, by the way. She's very far away, though. She doesn't. She says hi, Haley. But she doesn't want to interact with me, I guess. She's sitting as far away from me as possible in the room. So it's the outer crust of the earth, right? That's broken into these plates. Okay.
Is Haley in here?
So she is.
Hi, Haley.
How did oceans form, right? Because the plates are separating, water's condensing, water filled the spaces that were low, right? The basins, right? Obviously, they're not going to form on a mountain, right? Because it's high. Common sense. So let's talk about kind of how this process works more in depth here. Tectonic plates and oceans. So we have two kinds of plates really that we care about in this particular lesson. Spreading centers. In other words, when two plates are moving away from each other, right? Magma is being pushed up, usually in that spot, and you're forming new crust. So if that's happening in the middle of an ocean, you're forming new oceans, right? Or new parts of the ocean, probably not a new ocean. You're adding to the space that that ocean can fill. Subduction we'll talk about on the next slide, but that is actually the trenches, right? You guys might have heard of deep ocean trenches. That's where all the weird fish with the lights on their head live and stuff like that. Yeah, right? Some really creepy animals live in those trenches, right? Of course, because they're dark and weird down there. And then, of course, this new crust can increase the size of oceans when the plates move away. So there's a map here of the mid-ocean ridges. So all of these red lines show us places where the ocean is separating, right? Or the plates are separating, really, and the ocean's getting bigger. So there's a huge one in the middle of the Atlantic Ocean, right? So very slowly, we are moving further and further away from Europe, right? Of course, you could calculate that rate if you'd like, but it's really slow. At the same time, we have some other ones happening in the Pacific Ocean, right? We have some happening in the Indian Ocean. So they're all over the world. We're increasing the size of some of these oceans. Of course, other oceans or parts of the ocean would be getting smaller, right? Because the Earth can't increase its surface area. So, well, at least not in that way. Subduction is when one of the plates actually goes underneath the other plate. And we can have two situations here. One situation is if it's next to the continent, right? In other words, like let's say that this is Oregon and we have the ocean here and we had subduction occurring, there would be a humongous mountain range, right? Because the continental crust would get pushed up into a mountain. If this happens in the ocean, like it does here next to the Japanese islands, right, we get something called the Japan Trench, where we actually end up having basically a deep trench in the ocean. There's a ton. Probably not. So then we look at a map where we see other examples of where subduction is happening. Right, this one is confusing because it shows both, but the red lines are subduction, where the plates are touching each other, and the blue lines are spreading centers where the plates are moving away from each other. Right, so you can see that all these things are happening kind of at once, right? So if they're happening near each other, then really that ocean probably isn't changing that much. And again, this is slow. Like millimeters per 100 years, kind of slow, right? Sometimes it could be fast, but usually not. All right, now that I bored you with subduction in the oceans, we're going to play a true-false game. So everybody get ready to respond in the chat with trues or falses. Okay, first question. Ocean formation is a continual process. True or false? I'm seeing lots of T's. Good, it's true. Right? It's continuing. They're constantly changing. They're never going to be done, right? Subduction can form mountains if it occurs next to a continent. Lots of T's and trues, also true. Spreading centers are when plates collide. Think about the word spreading. Would that mean colliding? So that one is false, right? Spreading centers are when plates separate. Just think about what the words themselves mean. That'll give you a hint here, right? Spreading apart, colliding together. Tectonic plates have nothing to do with oceans or ocean formation. True or false? Okay, that one was kind of obvious. We just talked about tectonic plates for like 10 minutes. All right, that one's false. Okay, this one is like, who was really paying attention on that first slide? 99% of Earth's water is in oceans. False, right? It was actually 97%, right? Oh, excuse me, 70, well, of Earth's water, though. Yeah, 71% is water and 97% of that is oceans, right? So 99 was none of the numbers. Okay. Salinity. We're almost there, guys. Sounds like salt is the amount of salt, right? Now, how did the salt get there? Many ways. And remember, this is over time. Oceans didn't start out being salty. So we're not talking about the creation of salt. Salt existed, right? But they didn't start out being salty. How did they get salty? Well, first of all, salts, right, are naturally occurring. They're in rocks. They're on land. So as land and rocks eroded, salt got dumped into the ocean. Rivers and streams, guess what? They're going through all these rocks. They're also collecting salt, right? Salt dissolves very easily in water. Rivers and streams are dumping into the ocean. And then eventually, think about this. This is where it gets kind of like, oh, duh. Evaporation starts happening, right? Water evaporates. Does salt evaporate with the water? No. So the salt kept staying in the water, and the water continued to evaporate over hundreds and hundreds and millions of years. And it ended up being that oceans became more salty. So it's a slow process. Now they're salty. The average salinity in the ocean is 3.5%, right? So that's not that salty. Although if you taste salt water from the ocean, right, it tastes really salty, right? Yeah. Yeah, it doesn't taste great, right? But it's only really about 3.5% salt. Of course, that's the average, right? Some areas are going to have more evaporation, so they'll have more salt. And then, of course, this is where the science comes in. More salt equals more density, right? So when their salt water is heavier or denser, right? Heavier is not really the correct term, but it's a good way to think about it. Salt water is denser than fresh water, which means it will sink to the bottom. Right? So if we have a river and an ocean meeting, the river water that's fresh water will be on top, salt water will be underneath, and they kind of churn together. Some animals actually, that's where they need to live, right? Is where salt water and fresh water are meeting. So density is going to be a huge part of this. So we're going to watch this little video where we're going to see sort of how ocean currents work based on the different densities, right, between the different types of water, essentially. Okay, so wait, let's pause for a second because there's a lot of reading here. Left tank, okay, so on the left side, we're gonna see low salinity, not a lot of salt. Middle tank is gonna be medium salinity. Right tank is gonna be high salinity, okay? I don't know what this music is, but no, there's music on this video, flutes. Okay, so pause again. This tank here on the left, low salt, medium salt, high salt. So what would we expect to happen? What color is going to go on the top? Low, medium, high. The least salty is going to go on the top? Yes. Thank you, Juliana. Right, so we should see green rush to the top. So let's see what happens when they remove these little barriers. Yep. It's quick.
That did work quite well.
So then what happened, right? The lowest salinity.
So can anyone fill us in on what's happening here?
Was the green, right? So it's on top. The densest or the most salty was the yellow, so it's on the bottom.
Just head out of the way.
And the blue's in the middle. And of course, there's some mixing between.
Beautiful layers.
Okay, we don't care about what this guy's saying. There's some mixing between the blue and the green, right? And the yellow and the green. So you can kind of see some weird other coloring happening there, right? But that's the concept here where when we get currents, right, the movements of water can actually happen because of salt. And then I don't think they do anything else in this video. I just really liked that. We'll watch that removing the things again because it's cool. Okay. One more time.
Okay, it's recording. Yep. That did work quite well.
Okay. So that's pretty cool, right? There's a million videos like that on YouTube, by the way, if you want to watch water get mixed together. So then we can see things like this where we see a salinity map, right? Where we actually see concentrations of salinity, right? And we notice that there are certain parts of the ocean where it's saltier than others, right? Again, that's going to be based on rates of evaporation. You'll notice a lot of the super salty parts are pretty close to the equator, right? Because there's a lot of, what can you imagine, evaporation there, right? So it's saltier. Okay, so also temperature is important here and contributes to the ocean currents. So this is straight from Canvas, just some definitions of the 3 zones of temperature, right? They're kind of common sense, but it would be useful to write them down, especially thermocline, because that's a weird word. But we have our surface water, our thermocline layer, and then our deep water. So surface water is what it sounds like. It's the top part of the water that's getting the sun, right? And it's at a relatively constant temperature. You'll notice this if you ever go in the ocean or pool on a really hot day, right? The top of the water, you're like, ooh, this doesn't feel bad. And then you get in and it's really cold in the bottom. That's happened to me. The thermocline is the middle layer, right? This is a layer of rapid temperature change. So as the solar energy decreases with depth, the temperatures quickly drop, right? So then the thermocline layer is kind of constantly changing temperature and is going to kind of depend on the climate, right? If it's already cold somewhere, then the thermocline layer is going to be colder. And then deep water is most of the water, right? What's approximately 1,000 meters and lower. And it's really cold, close to freezing. So again, we probably haven't been in deep water that much, if at all. Okay, so then what causes water to circulate? Right, it's this temperature differences and the salinity or dissolved solid differences, right? So not only does salt dissolve in water, other things. Magnesium dissolves in water, carbon dissolves in water, oxygen dissolves in water, other stuff dissolves, right? And it's sort of this unevenness of all these things that actually cause currents, right? So we call these currents based on temperature differences thermohaline circulation, right? Where does that come from? Well, it comes from this thermocline layer, right? Yeah, it does kind of sound like Haley a little bit. The thermohaline circulation, right? So a common example here is warm water circulates up close to Europe, right? And then cold water circulates down. Now, this is important for the climate of Europe. Because of this warm circulation right here, it actually makes their climate more mild, right? Whereas it should be way colder there if they didn't have this ocean current, right? So ocean currents can actually contribute to the climate. Okay, we're gonna watch one more video of the water mixing, but this time it's gonna be temperature. This guy's kind of boring, but we'll listen to it.
Hi, my name is Jason, and I work at the Canada Science and Technology Museum. Today we're going to be doing an experiment on water density and seeing what happens when two different densities of water mix together. You'll notice I'm standing in front of the Titanic display, but more on that later. For now, let's head to the lab. Every day, vast bodies of water mix together. It could be where rivers meet, at water treatment plants, or where cold ocean currents mix with warm ones. When rivers meet the ocean, fresh water mixes into salt water. These bodies of water each have different densities due to variation
Don't know about
in
these camera
temperature or
angles, but
salinity. Now we're going to see what happens when we mix water at two different temperatures together. In this side, I have cold tap water. We're going to mark that with blue food coloring.
okay, makes sense. Cold is blue.
In this side, I have hot tap water. We'll mark that with red food coloring.
Red is warm.
I'm going to open the gate, allowing the two temperatures to mix. As you can see, there's a distinct separation between the two temperatures. The less dense red water is on top, and the denser blue water is on the bottom. Just to contrast this, we're going to show you what happens when we mix water that's at the same temperature. With the water at the same temperature, there's no density differences, and the mixing is much more uniform, giving a...
Okay, so then he talks about the Titanic. You can watch that later if you want. But basically the concept here, right, is that the temperatures of water can cause currents, and the saltiness or the minerals of water can cause those currents, right, basically by changing the density of the water. So warm water is less dense. It's going to go to the top, right, and cold water is going to go to the bottom. Think about it like air, right? Warm air rises because it's less dense. So really, when we're thinking about ocean currents, we're thinking about salinity and also temperature are causing those currents. Okay, we've reached the end. So there is a code word today, which I'm about to type in the chat. You will be able to use it for a +5 on your 6.01 quiz. You guys are gonna like the code word. Okay, so it's up to you though. You gotta type it in either the comments or in one of your answers to say that you want your +5. If you happen to get 100 on the quiz, right, then I'll let you know you can use those points on something else. Next Friday, we are not having a virtual session. I'm going to be on the planetarium field trip, which we would maybe be getting back right when this session's about to start, but I don't want to risk it, right? So we're not going to have a virtual session next week. I will also send an email reminder about that, right? But write it down right now, February 23rd, no virtual session. Use your code word to get your points, right? Otherwise, does anybody have any questions about ocean characteristics? All right, I'm going to say probably not, because really we just learned a ton about them. All right, so this PowerPoint and the video will be posted later today, and I expect to see a lot of 6.01 quizzes turned in, and I will see you guys in 2 weeks. Okay, bye.